Hello and welcome to a quick preview of IsoCAM, two pieces of software for CNC milling or CNC turning without having the need for C.A.D. You will see the screen is divided into four separate areas. The top left gives you a list of files that you've created. The central screen is a script file that you're going to create or edit. The top right gives you the actual CNC program created, and the bottom right shows you a graphical verification of the program that you've actually created. So how do you actually create a CNC part program? In each screen you can right mouse click and it'll give you different options. In the top left on the screen I'm going to mouse click and get a new CNC script file. You'll see at the bottom right hand corner of the screen it says script file error, drawing number has not been specified. Enter drawing number. And it'll say drawing description has not been specified, so we're going to specify drawing description and we're going to call it a test. Then under main program start, you click under main program start and right mouse click, and you've got the option to 4 5 to rotate, change tool or put a comment in. So I'm going to change the tool, and under this option you've got various options. By clicking on tool description, then right mouse clicking, you've got face mills, ripper tool, then mills, drills, reamers. And depending on what tool you actually pick is dependent on the actual geometry going to be created later. I'll just show you quickly a drilling operation to show you the different options available and how easy it is to create it in different controls, for example Fanuc or Heidenhain. So I'm going to pick a 18.5mm diameter drill, and another error comes up, depth A. Obviously you need a depth to drill, so I'm going to put 20mm in for my drilling operation. Then under tool chain, if you right mouse click again, you can now subroutine start. This is the actual creation of the geometry. So press subroutine start, then right mouse click again, and you've got your options. Because it's a drill, you can only do drilling operations. If it was a face mill, it would only do face mill operations. At this stage you can import C.A.D data, but you can also create the geometry by selecting any of these particular sections. I'm going to do a pitch circle diameter, so click on that and you've got your options down here. And all features that will come to in a short while. But you've got your centre of coordinate of your PCB, your pitch diameter, number of holes, first angle position, start angle and reference quadrant. So my number of holes I'm going to say is 18. And as soon as you change that, the actual graphical verification of the software is updated. Now for reference purposes I'm just going to change the centre position, say to 120mm and vertically 100mm. You see at the moment that the top two holes are off centre. If I click on first position and right mouse click, I get the option to put it on centre, which means that the topmost hole would be on centre line. You'll see it's updated that. It's also updated the program, but at this moment you can't actually see it. Now on component handling, you've got right. If you right click that, you've got right or left. If you've created a script file for a right hand component, then you want a left handed component, all you have to do is select left. So if I do that now, you'll see that my green centre line, which represents my datum, has changed. And all the coordinates for all the holes have been mirrored. Now it's not just a case of putting pitch circle diameter into the actual program. You carry on doing various other things. You can carry on putting another pitch circle diameter, pitch arc radius, square pitch, rectangular pitch, triangular grid, a Cartesian coordinate which is an x, y coordinate, a polar we specify its centre point and radius, or you can set subroutine end. So I'm now going to put a square pitch in, and you'll see it's put a square pitch in. I can rotate that pitch by putting 40 degrees in, and it will rotate the actual program itself. I'm going to say subroutine end at this point, but at any point in the future you can go back into this section, click in any area which is clear, right mouse click, and you can carry on adding bits on. So I'm going to actually add now a pitch circle radius, so pitch arc radius, and you see it's actually created one there. We'll go to right hand pull, and we'll change the radius to 50 millimeters. And you see at the moment it's not been specified because the radius value is 0. And there is your radius. Now let's go back to left hand component, and you'll see that the radius has been mirrored in effect. So all the x plus coordinates are now the x minus coordinates. But you can turn certain features off. You'll see that it says and all features. By saying and all features, all the old coordinates will be mirrored in the x-axis, so the plus values will become minus values. But you can actually switch this particular section off. For example, on the pitch arc radius, if I say and all features no, you'll see that it's kept the actual coordinates in the right position. So how do you change from Prototrak to Fanuc or Heidenhain? Now to do this program longhand would take quite a while, but by using IsoCAM, if you click on machine tool name, you've got various options. I've got 3 machines here. AS is going to be Fanuc, Bridgeport is going to be Heidenhain. So if I click on AS, you'll see the program is being created. Click on Bridgeport, and the program has changed directly to Bridgeport. You will also see in the bottom right hand corner an estimation of the machine cycle time, in this case 7 minutes. That is a quick demonstration of how easy it is to create geometry within IsoCAM. You can do pocketing, circle pocketing, rectangle pocketing, profiling, face milling, slot drilling, and the lathe option is something similar, but you actually create the geometry by answering quick questions in a script file. It is easy to use, very quick, easy to convert into different languages, and is available by looking at www.isocam.co.uk. Thank you.